Hello everyone, this is Sudarshan Sharma once again here after a long interval of time with 10th class physics. Well, today I am going to help you out with electricity chapter, much awaited chapter on the demand of the several students. See, my dear students, this chapter is very easy. If you understand the basic concept of this properly, we will definitely clear all the concepts. So if you are able to get the concept, if you have any query or any doubts later on, you can write and I'll definitely try to respond and try to rectify it. Fine. So we'll solve some numericals also later. So right now I'm going to focus on the content, that is of electricity, electric energy, which is of 10th class physics. So if you like my video, please do not forget to share it, give a thumbs up and write your comments for the further improvement of the video. So today I am going to discuss with you is about electricity. So electric energy, basically electric energy is of two types. One is electrostatic and another is electric current. So what is electrostatic and what is electric energy? What is the difference between the two? Electrostatic. Static means at a state of rest. Electro means related with the charges. Okay. So in electrostatic we study about charges at rest. Whereas in current electricity, electric current, or you can say it current electricity. So charges are in motion. Charges are in motion. Which type of charges? What are the types of charges? Now I will discuss. There are two types of charges. One is your positive charge and one is your negative charge. See, positive charge is on the proton, whereas negative charge is on the electron. So proton, which is at the center of the nucleus. Suppose this is your atom, and at the center of the nucleus only protons and neutrons are residing. Protons are positively charged particle and neutrons are neutral. There is no charge. And electrons are revolving in the shells and subshells outside. Electrons. So first shell can accommodate your two electrons. So these are relatively free, whereas protons are bound to the nucleus. They are bound to the nucleus because of the strong nuclear forces, but electrons are relatively free, so they can move. Okay, so in electrostatic we study the charges at rest. So at rest, how? I will give one example. You can take a plastic pen and rub it with your dry hairs and take small bits of the paper, and if you will bring it nearby it, you will see that these small bits of paper are getting attracted toward the pen. Why it's happening so? It's happening on account of the electrostatic charges. How? What's happening basically? So it's acquiring basically negative charge. By convention we say it's acquiring negative charge because electrons are getting transferred from our hair on account of the friction to the plastic pen. So when you bring it nearby the bits of the paper, they are getting attracted toward this. So many small type of experiment you can do yourself also. Whereas in current electricity, the electricity which is supplied to our domestic purposes, we study about that. Charges are in motion, electrons are moving. So current is flowing from one terminal positive to the negative. So positive generally proton and negative generally electron. So without electricity we cannot today imagine our life comfortable. Our LED, our TV, our small devices, mobile phone, our batteries, our AC, our fan, each and everything is running with electricity. The light after in the evening which we are using, which we cannot imagine our life comfortable. Electricity is one of the most important discovery of the 19th century. So all the contribution of so many scientists and physicists. So here comes your charges, two types of charges. In this chapter we will mainly concentrate on electric current. So types of charges. What are the various types of charges? There are two types of charges. One is positive charge, which is on proton, just I said. So charge on proton is how much? We can write by E positive also, is 1.6 into 10 power minus 19 coulomb. And second is your negative charge, which is on electron. So you can write this plus and you can write this minus. Charge is same for both, 10 power minus 19 coulomb. Difference is one is positive, one is negative. And the mass of electron, whereas mass of electron is 9.1 into 10 power minus 31 kg. For numerical purposes you can remember. And mass of proton is 1.67 into 10 power minus 27 kg. So now let's talk a little bit about the properties of charges. Okay, so these charges, how they interact with each other, and what is this unit about this also I'll let you know. This is called C, stands for Coulomb, C-O-U-L-O-M-B, after Coulomb's law. So let's discuss about the properties of charges. So properties of charges. Similar charges repel each other. Positive will repel, and negative will also repel each other. So suppose this is Q1 charge and this is your Q2 charge. So if it is positive and R is suppose distance between them, if it is positive and it is negative, then the equation changes and we say opposite charges attract each other. So if R is the distance between them, so how they are interacting each other? They are attracting each other rather than repelling. They are attracting. This is called force of attraction. It's given by C-O-U-L-O-M, yes, Coulomb's law. According to Coulomb's law, Coulomb has given the statement of this law. So according to Coulomb's law, the force of interaction means attraction as well as repulsion, is directly proportional to the product of charges and inversely proportional to the square of distance between them. square of distance between them. Mathematically, how you write this? So, mathematically, F is proportional to Q1 into Q2 upon R square. F is equal to K times Q1 into Q2 upon R square, where K is constant of proportionality and its value is K is equal to 1 upon 4 pi epsilon naught. So F is equal to 1 upon 4 pi epsilon naught Q1 into Q2 upon R square. So you can write this formula, and this is called Coulomb's law. After Coulomb's law, the SI unit of charge is called as Coulomb. The SI unit of charge, whether it is positive charge or negative charge, is called Coulomb. It's represented by C. So SI unit of charge is SI unit of charge is Coulomb, capital C, represented by capital C. So now we will talk about the current. Topic is now, next topic is current. Now the current is two types. One is your AC current and one is your DC current. About AC and DC in detail we'll talk about in the next chapter, in the next video. But right now, current. What is current? How do we define it? Okay, so we'll study about this. Current, the rate of flow of charges is called electric current. It's called electric current. So it is represented by I is equal to Q upon T, rate of flow of charge, or sometimes we write it dQ upon dt also when we take it as instantaneous charges. Limiting value of this, then we can write, for the time you can remember like this, and for your class 10th it's enough. So Coulomb per second will be is a SI unit, or we call it ampere. A-M-P-E-R-E, ampere. SI unit we can write Coulomb per second, otherwise we generally write SI unit of current is ampere. So how you will define 1 ampere? 1 ampere. 1 ampere. The current flowing through a conductor is said to be 1 ampere. 1 ampere if 1 coulomb of charge flows through it for 1 second. So 1 ampere is equal to 1 coulomb upon 1 second. So this is the way how you can define 1 ampere. Sometimes this definition is asked during the exam. Okay, so what is current and how do we measure current? How we do measure current? We measure current with the help of an instrument which is called as a meter. A-M-M-E-T-E-R. This is an instrument in which there is a reading from 0, 1, 2, 3, 4, 5 and so on like that, and this is moving coil of the moving coil type galvanometer, where we write A here, and this line represents that is it working with AC. And if it is working with both, then here is one more line which tells you about DC current. So this is ammeter which helps us to find out the current, to measure the current in a particular circuit. Let's talk about now the types of, when I talk about the circuit, let's talk about the circuit, electric circuit, and the symbols which we are using. Electric circuit. See, this is your electric circuit which comprises some electric bulb. This is your bulb symbol. I'll tell you all the symbols which we are using. And this is the symbol of cell, and this is symbol of your switch. Okay, the switch. When you will switch on this and it will on, then the current will start flowing from positive to negative. Then it is said to be a closed circuit. Closed circuit. So bulb will glow. The current will flow from positive to negative. Whereas conventional current, we call it conventional current, from positive to negative. Electrons flow, electronic current is from negative to positive. Okay, so when the circuit is open, this is closed circuit. When the circuit is then open, so open circuit, OPEN, open circuit, when it is like this, not connected. Or sometimes instead of switch, you can get a symbol like this. This is open circuit. And when you put dot over here, then it is called as closed circuit. So other symbols which we are using, I'll tell you. So this is circuit. Circuit comprises your some electric resistance, your cell, your key, etc. Your ammeter can be also there. Ammeter is always connected in series. How do we connect ammeter? This is a series circuit, so ammeter is connected like this. Ammeter is always connected in series. Remember it, very important thing. So the next thing which I am going to tell you is about the different type of symbols which we are using there. Right now I have shown you cell. This is your symbol of cell. If so many cells are connected together, this is big one, shows your positive, then negative, positive, alternatively is right. So this is called battery. And this is called your open circuit. Open. And this will indicate your closed circuit. And this is your switch. This is your switch, open switch. And this is your closed switch. Closed. Fine. So this is symbol of your ammeter, and this is your voltmeter, which is used for measuring voltage, and this is your galvanometer, just to find the presence of current. Galvano and ETR. This galvanometer can be converted into ammeter as well as into voltmeter. Okay, so this is your resistance, symbol of resistance. Resistance. And this is symbol of your variable resistance. Resistance, constant. Which type of resistance? Constant. Variable. RESISTANCE. There is one more symbol like this only, which is called rheostat. Okay, Some more symbols if you want to know. Connected wire and cross wire. This is enough. I think this is enough for 10th class. Let's go ahead with some more things. Let's talk about potential, electric potential, which is the next concept, very good concept. Electric potential. It is represented by V, electric potential. See, in order to understand electric potential, I can give you some example. For example, there are two iron balls, ball A and ball C. C ball is cold, it's at low temperature, and ball A is hot. You can write it ball H then. It's hotter ball and it's cooler ball. So this hot ball, when you will bring into the contact of cool ball, heat will transfer from hotter body to cooler body. Similarly, if you have a water tanks like this, and you connect these tanks with each other with the help of a wall. Here is a wall. Okay. So as this is fully filled and this is less filled. So as you will open it, the water will flow from higher level to lower level because there is a pressure difference. Fine. So in the same way, current also flows from higher level to lower level. So this is called as potential. This is because of the potential difference. One is at higher level, one is lower level. So current will flow always from higher level to lower level. The way heat is flowing from hotter body to cooler body, and water is also flowing from higher level to lower level. So similarly, this is called as electric potential. And electric potential is maintained by an electrochemical cell, battery, or some other devices. So electric potential, how do we define electric potential? This is an important concept. This is amount of work done in taking a unit positive charge from infinity to the point in an electric field. So this is amount of work done. So it is represented by V is equal to W upon Q. Charge, work done per unit charge is called as electric potential. Amount of work done in taking a charge from infinity to a point in an electric field. Now I'll tell you what is electric field also. So this work is done against the electrostatic force of attraction or repulsion. So that work done is stored as electrostatic potential energy. So electric potential is work done per unit charge, and its SI unit is you can write joule per coulomb also, but otherwise is volt. It's represented by capital V. So here comes another similar type of concept which is called as electric. Let me define first of all electric field, then I'll tell you about electric potential difference. Electric field. Electric field. What is electric field? Basically, electric field is a space around the positive or the suppose isolated negative charge we have. It's a space. Electric field is a space around a positive charge or a negative charge. An electric field is space around a charged particle in which its force of attraction and repulsion can be experienced by any other positive charge. You can write it more detail. So it's given basically by, it's represented by capital E, force per unit charge. Force, where F is your electrostatic force, and its formula, if you want to write, then it is 1 upon 4 pi epsilon naught Q upon R square. Whereas force formula was 1 upon 4 pi epsilon Q1 Q2 upon R square. So you can compare and can remember by the comparison. So this is the electric field. What is this? Space around this. If I will bring some charge, suppose I bring a positive charge, it will experience the force of the repulsion. So it is the amount of work done, electric potential amount of work done in taking the charge nearby it from infinity. Why we say infinity? Because at infinity the electric field is zero. There is no influence. Infinity means very large distance. At large distance, as we go far away from the charged particle, the electric field is decreasing. At infinity, it's considered as zero. Fine, there is no force on the charge at infinity. So this is about electric potential. Now I'll talk about electric potential difference. Electric potential difference. Nearly same definition of electric potential, little difference. The amount of work done in taking charge from point B to point A. Say point B to point A. So VA minus VB is given as work done per unit charge. So this is also electric potential. We call it potential difference. Potential difference. So if you can take it VB minus VA, then from A to B, the work done taking from A to B, and you can write here also A to B or B to A. Okay. So potential difference, again it is measured in volts. So after electric potential, what is the relationship between electric potential and electric current was given by Ohm's law, OHMS, Ohm's law. So I forget to tell you that electric potential is measured by voltmeter. Although I told you, I think in the symbols. So this is voltmeter. One thing which you should remember, that voltmeter is always connected in parallel. It is connected always in parallel, whereas your ammeter is connected always in series. This is your resistor. So above the resistor or below the resistor, it is connected in parallel. It measures your voltage in, suppose 0, 1, 2, 3, 4, 5 volt and so on. So you will see here a needle which will move, and this is your volt. Okay, depends AC or DC volt or sometimes both. So you can find out what is the voltage. It is always connected in parallel, please remember it. Whereas your ammeter is always connected in series. This is your ammeter. We can continue with this circuit also. So I can come here with positive, negative, positive, negative. I connected a battery, and the current will flow in this like this, positive, negative. And you can connect your rheostat switch here. Okay, so we have a resistor, or you can say rheostat. This is rheostat which is connected here. So the current will flow in this like this. So ammeter, voltmeter, and this is the Ohm's law circuit. What is Ohm's law? This is an apparatus with which you can find out the relationship between the current and the voltage. Okay, let's write down the statement of Ohm's law. According to this law, if physical conditions are kept constant, then the current flowing through the conductor is directly proportional to potential difference. To potential difference. V is potential difference and current I is the current. So I is proportional to V. V is proportional to I. V is equal to R times I, where R is constant of proportionality. Called resistance. So you can write, which implies R is equal to V upon I. So from here we can define resistance. What is resistance? And we can define resistance as potential difference per unit current. Okay. So it's a one of the very important concept, resistance. I'll discuss after this. What is this Ohm's law? Ohm's law is basically relationship between current and potential difference. When we do this experiment, we vary the rheostat from here. The current is changing simultaneously, your voltage is changing, and voltage is changing. Obviously, your current will change because there is a direct relationship between current and voltage. Okay, current will change, potential difference means voltage will change, V will change, then I will change. Provided things like your temperature, etc., are kept constant. So this is one of the conditions which we have to remember. This is Ohm's law. So SI unit of resistance is also Ohm, after the name of George Simon Ohm, a German physicist. So let's talk about the resistance now. Resistance R. Basically, what is resistance? Every object, every metal through which the current is passing is having resistance. So resistance, even insulator and semiconductors, other substances do also have resistance. So resistance is an obstacle in the path of the current. So resistance is an obstacle in the path of currents. Its SI unit is R is equal to V upon I. Formula you have to remember. SI unit of resistance is OHM. Symbol is, this is the symbol of resistance. How you will define 1 ohm? Sometimes question comes. The resistance of a resistor is said to be 1 ohm if 1 volt of potential difference is applied and it allows 1 ampere current to flow across it. So 1 ohm is equal to 1 volt upon 1 ampere. 1 ampere. So how do the resistance depends upon the various factors? What is resistivity and what is specific resistance or resistivity, same thing. So how it depends upon the length of the conductor, area of the conductor, and what are the various numericals which we can solve with the help of this, and how resistances are connected in series and parallel, There are articles on that. There are so many numericals and several type of the circuits are there. This I will discuss in the next video. If you like my video, give me a thumbs up to motivate me. You can share with your friends, subscribe it, press the bell button. That's all for today's lecture. Thank you very much.